a los temas que tienen que ver con la discriminación y con la presencia de actitudes implícitas que probablemente tiene su origen en que ella es una persona que viene se fue a estudiar, digamos, psicología, llegó a estudiar psicología social. ¿No se está escuchando? ¿Ahí sí? Ya. Entiendo que el plan no era originalmente que Buyu se convirtiera en una psicóloga social, pero desde su país natal, de la India, llegó a estudiar en Estados Unidos y se formó en el momento que se estaban desarrollando la investigación sobre actitudes implícitas, y ella es una de las expertas más importantes en ese ámbito, quien trabajó con Tony Greenwald, con Panaji, entre otros, durante también sus estudios doctorales, y ha hecho grandes contribuciones en ese tema. Y mantiene una línea en que conecta justamente cómo los aspectos no explícitos pueden ser la fuente o dar forma, digamos, a muchas de nuestras conductas y actitudes. Y esto ella lo ha conectado con distintas categorías sociales, principalmente, o una de los focos principales de su investigación ha tenido que ver con género, pero género también conectado con otras condiciones minoritarias, por ejemplo, étnicas o de carácter social. En los últimos años ha estado trabajando también en el impacto que tienen este tipo de diferenciaciones en el largo plazo en la vida de las personas, tanto cuando las actitudes implícitas, qué impacto tienen en las mismas personas, la conciencia que tienen de su condición de pertenecer a un grupo sobre el cual existen este tipo de influencias implícitas, como también en el largo plazo, incluso en la carrera, en decisiones que tienen que ver con el futuro laboral o profesional de las personas. Y creo que sobre justamente eso va a tocar hoy día esta línea de investigación que he estado trabajando más recientemente, que conecta algo que para quienes trabajamos aquí en este centro nos resulta muy, hoy para mí como para mí, que tengo una identidad un poco dividida entre la psicología social y la política con la medición y la educación. Buyu está exactamente trabajando en este momento, justamente como nos va a mostrar, cómo se conecta justamente el tema de la presencia de lo implícito en el contexto educativo. Así que es, como digo, un gran honor. Además es una persona que tiene una motivación y una generosidad para compartir su conocimiento muy grande. Esta es la segunda vez que nos visita en Chile y confiamos que vamos a poder extender la colaboración, especialmente en los temas en que ella está trabajando ahora hacia adelante. Así que muchísimas gracias.
So I am a pacer, so I'm going to pace around. If at some point of time you can't hear me, you should let me know. So first of all, I think one of the best things about being an academic is you get to go share your research and your ideas with people all across the world, and it's, I think, one of the most privileged kind of work that you can do. And I think, so I can't imagine a better kind of work or profession to be in. So I'm really curious about your ideas and your thoughts about the research I'll present. And even though the research I'll talk about, the data I'll talk about, are all based in the US, I think many of the phenomena generalize across the world, including Chile, and there may be some similarities and some differences. So I'm very curious about, oh, if the microphone isn't working. Yeah. Is it on? No?
Okay, use another.
Yeah? Oh, wait.
Yeah. Please.
All right, let me check this out. It was working. Maybe not. Oh, this is on.
This is, it's normal, but this is problem.
And Hector, who invited me here and planned this whole trip. And I think it's because all of you are lucky to have people like that to organize this event, that stuff like this happens. So anyway, I know your custom is to hold questions till the end, and if that works better for you, that's totally fine. But if you want to interrupt me and ask questions as we go along, that's fine too. So do whatever feels comfortable to you. So my research, as Jorge described, a lot of it is on implicit bias. The strand of work I'll talk about today is about gender inequality. I'm particularly interested in social inequality. And the work I'll talk about today is about gender inequality in education, particularly in science, technology, engineering, and math, which in the US is often abbreviated as STEM fields. Science, technology, engineering. And the reason this matters is because the kinds of fields students self-segregate into and self-select into determines not just their majors and their university degrees, but ultimately influences their career paths, which has massive sort of repercussions for society, but also for economic equality or inequality. And I'll say more about that in a second. So imagine two students, student A and student B, both in elementary and secondary school, are equally enthusiastic and interested in science and math. Both do equally well in these fields. They go on into high school, and now both are still, student A and student B are still doing equally well. But now student A becomes less interested, sometimes feels less confident in their ability, and student B begins to participate more in science and math classes. They both graduate from high school, they both go to college. Student A majors in psychology, student B majors in chemical engineering. If you guessed that student A was female and student B is male, you would be right. And that is the story of many girls and boys, many men and women across many different countries. So let me show you a graph to illustrate what I mean. So these are international data that some of you may have seen before about performance on standardized tests in science across several countries. And so here's Chile, here's the US, and all the other countries. And you can see when it comes to test performance on the PISA science test, a standardized science test, girls and boys are doing equally well. Right? There is no gender difference in actual test performance. But if you look at what kind of degrees these students take when they go to college, you see huge gender differences where women are far less likely to major in science-oriented fields than their male peers. If you look at mathematics, you find a similar and even more exaggerated, if anyway, pattern such that in terms of actual ability and test performance, you see either equal or very small gender differences in test performance. And testing may be one measure of ability. But then if you look to your right at who gets math-intensive degrees in engineering, in mathematics, in physics, chemistry, you see a huge gender difference. So equal ability, but very different pathways in academic degrees. And the reason this matters is because the number of women who get degrees in math and science determines who ends up in professions related to science, engineering, and technology. And so it's no surprise that there is a relative scarcity of women in professions, in STEM professions. And this matters because these STEM professions are some of the fastest growing professions across the globe. And these are also some of the best paying professions. So what starts off as being educational gender differences ends up becoming economic and income disparity between women and men, even among those who are college educated. And that's why it matters. It's not simply an education difference, it's also an economic difference. So the question that I'm interested in is why do these differences happen? What causes these differences in educational and professional pathways? It's true, no doubt, that discrimination, glass ceilings, disparities in resources are one sort of explanation. But I think that's not the full story. Some recent reports have argued that there's another kind of reason why those gender differences happen, and that is sometimes girls and women who are very talented and qualified choose not to pursue academic and professional pathways in STEM fields because they would rather do something else. And this is a position taken by many articles, but one of them, my personal favorite, is an article entitled, the quote, "Freedom to Say No to Careers in Science and Engineering," where the journalist cited social science research trying to explain why there are these big differences in who pursues STEM fields. And she argued, I quote, "When it comes to certain math and science related jobs, substantial numbers of women, highly qualified for the work, stay out of those careers because they would simply rather do something else," unquote. In other words, women have the freedom to say no to careers in science and technology, and if women choose that freely, why should we as a society have a problem? The problem, I see, is that the assumption underlying this article and the data on which it was based is that the decision to choose one discipline over another, one profession over another, the assumption is that is a free choice determined solely by one's talent and intrinsic motivation, as if it's unconstrained by societal forces. But the question driving my research is, are these choices really free? Might individuals' freedom be constrained by subtle cues in achievement context that signals to the person who naturally belongs there and who doesn't? So I propose that individuals gravitate towards achievement fields where they feel they belong, they feel comfortable, and they feel that way because it's sort of consistent with positive stereotypes of their own group. And individuals tend to move away over time from other fields where they feel like a misfit, where they feel uncomfortable because those fields deviate too much from own group stereotypes. If this is the case, then the question is, what factors might release these constraints and increase individuals' real freedom to pursue any academic or professional path they wish, despite stereotypes to the contrary? This is sort of the question that drives my work. And in order to address and test this question, I developed this model called the stereotype inoculation model. So let me give you a quick and sort of dirty definition of the model, and then I'll show you a visual representation. So the basic idea of this model is that just as biomedical vaccines protect and inoculate our physical body against noxious bacteria and viruses, so too, I would argue, that exposure to same-sex experts and same-sex peers protect and inoculate one's mind against noxious stereotypes. In other words, those experts and peers who belongs to that person's group function as social vaccines. So in shorthand, I'm going to call this the social vaccine hypothesis. But there are actually sort of 4 hypotheses that come from this model. So let me walk you through it. So first, I argue that an important factor that determines individuals' choices and decisions about what academic and professional field to follow or not depends on the environment, the local environment in which a subject or a discipline is learned and who they see in it. So who are the teachers and professors? Who are the peers in the classroom in that learning environment? So I argue that the more girls and women see same-sex professors and teachers and same-sex peers in that learning environment, whether it's a formal classroom or an after-school activity or whatever it is, the more likely they are to develop a sense of confidence or self-efficacy, the more likely they are to feel challenged rather than threatened, the more likely they are to develop positive attitudes towards that field, develop a sense of identification with that field, and further downstream, the more likely they are to want to participate, want to pursue that field even more, and over time it will lead to persistence and motivation. So that's the first prediction. Second, I predict that this sort of contact with in-group experts and in-group peers is far more likely to matter to students who belong to a negatively stereotyped group, like girls and women in science and engineering, and that contact with same-sex experts will matter less to students who are either positively stereotyped in that field or sort of the cultural default, expected to succeed. Why? Because for the negatively stereotyped group, coming in contact with experts who look like you essentially undercuts or negates the power of those negative stereotypes and makes it much more plausible to imagine that you can be that person. And that process is much more likely to be relevant for girls and women in fields where they are negatively stereotyped. It's less important. The gender of the instructor or the gender of the expert or the gender of one's peers is less important for boys and men in science and technology because the assumption is that they would succeed. So third, we predict that this sort of exposure to in-group experts will be particularly successful if that student identifies with that expert. Because the identification, feeling like I'm similar to her, makes the path from one's present self as a novice student to a future self as an expert seem far more plausible because one can imagine following the same career trajectory as that person. And finally, I think that the influence of these local environments on individual self-concept is often very subtle and implicit, in the sense that we often don't think of our decisions and choices and career trajectories as being influenced by other people. We think of it as being influenced by our own interests. We make an internal attribution, not an external one. But nevertheless, I'm going to argue and show you that oftentimes the presence or the absence of same-sex individuals in those learning environments had a huge effect on people's implicit self-concept, even if you don't see it in their self-reporting. So my students and I have been testing this model in many different ways, using many different studies, and what I want to do today is to give you a taste of several kinds of studies we've conducted testing this stereotype inoculation model, and all the data that I'll talk about will be on girls and will be on women and men at the university level. So these are 18 to 23-year-olds. My new research is on middle school and high school students, but we don't have those data yet. So it'll all be on university level students, and it'll all be US based. And I'm particularly curious about from you to hear about how much of these findings will generalize to Latin America, and to Chile in particular. So in one of our first studies, we wanted to test whether exposure to a same-sex professor in a STEM field, in mathematics in particular, would have any social vaccine effect for young female students in college. So I went to our North Campus and I made friends with my colleagues in the Department of Math and Statistics, and we conducted a study in calculus. Why calculus? Because calculus is a foundational course that's required for all STEM majors on our campus and across the country, and I'm sure in most countries across the world. So we conducted a study in calculus. It's a longitudinal study where we recruited female and male students from these introductory calculus classes, roughly equal numbers of women and men. There were multiple sections of this class, and it so happened that some of these sections were taught by women, female professors, some were taught by male professors. The beauty of this class is that all sections use the same syllabus, same exams, the same lecture materials, and grading was done in a de-identified or blind way. Right? So the content is the same, the only thing that's varied is the gender of the professor. So, and male and female professors had no idea what our hypotheses were. So they had no idea that they were part of our intervention. So here's what we measured, both at the beginning of the academic semester, when students started college, and at the end of the semester.
Did the students choose the professors?
Say that again?
Whether the students choose which professor?
Good question. So Hector is asking if the students chose their professor. The students didn't. In fact, the students pre-registered for the class over the summer, before the professors had been assigned to the sections. So they had no idea. That's actually a great question. They couldn't have self-selected into the section taught by their favorite professor. Yeah.
So the assignment is actually random, or is it in function of academic priority or something like that?
The student assignment into the courses is pseudo-random. It's probably entirely dependent on the student's schedule, course schedule. It's not dependent on who the professor was. It's not dependent on prerequisites. In fact, this is the prerequisite. They need to take every other course. So these are first-year undergraduates just coming into college who think that they might want to major in a science or technology field. So we measured a variety of things. So we measured students' attitudes towards mathematics compared to humanities. And Jaime set me up really well because we measured their attitudes both using explicit measures, which are standard survey instruments where we ask students, how much do you like math? or dislike? How fun or boring is it to you? And we asked that of both about mathematics and a humanities field. We also measured their attitudes indirectly. And some of you might know about how attitudes are measured indirectly, but if you don't, the basic idea is that an attitude is a mental association between a concept, like, let's say, mathematics, and a good or a bad feeling. So if I have a strong positive attitude towards math, when I think about math, those positive thoughts should pop into mind very quickly and easily. And those negative thoughts should be much slower to come to mind. But if I'm math phobic, if I fear mathematics, when I think about math, those negative thoughts should pop into mind much more quickly, and the positive thoughts should be much slower to come to mind. In other words, the speed with which those thoughts pop into my mind can be an indirect way to measure attitude strength. So implicit measures of attitude typically use reaction time on a computerized task that measure the speed with which a student is able to associate good words versus bad words with fields like math versus humanities. So in my studies, I always measure both implicit attitudes and explicit attitudes. And you'll see that all the results show up beautifully on implicit attitudes, on implicit measures, but nothing that the person self-reports makes a difference, which is sort of consistent with what I had predicted. So we measure students' positive or negative attitudes both using an implicit association test, or IAT, that Jaime had referred to before, and we also measure it using standard questionnaires. We also measure students' identification with math, which is to say, how much do they think math is important to themselves? How important is it to their self-concept? We measure it again using standard survey instruments, and we measure it using an IAT that measures how quickly students associate math with I, me, myself, versus math with not me. And that's, so again, an IAT. We measure their self-efficacy or confidence by asking them to predict how they'll do in the course, and we get their permission to get their final grade in calculus from the registrar, from the university registrar, so that we can get an accurate measure. So let me show you what we found. So I'll first show you students' implicit identification with mathematics as a function of the gender of the student, whether the student is male or female, and the gender of the professor. The black bars are female students, the gray bars are male students. Here is the female professors, here are the male professors. Higher numbers on the vertical axis means that they're strongly identifying with math. So faster association between math and me. What you can see is that for female students, when their professor is also a woman, they identify with math far more strongly than when their professor is male. But for male students, they identify with math equally strongly, regardless of the gender of the professor. Okay? We find the same pattern of data when we look at students' implicit attitudes towards mathematics. This time, negative numbers means that they are much more strongly associating math with bad and humanities with good. So what you can see is that for women, female students, again the black bars, when their professor is female, they like math and humanities equally. They make no distinction in their implicit preference for math and English. When their professor is male, they have a strong negative attitude towards mathematics. For male students, they like math and English equally, no difference. Yes?
Is this post-test?
No, this is both. So we measure their attitudes, we measure all of this. Time 1 is 3 weeks into the semester. Time 2 is 1 week before or 2 weeks before the end of the semester. Interestingly, we find no time differences. Once they are in the class for 3 weeks, whatever those attitudes and identifications are, stick consistently across the whole semester. All right, so the main takeaway from these two graphs is that for your female students, their identification with math and their attitudes towards math is jumping around as a function of the gender of the professor. For male students, they hold steady, the gender of the professor doesn't make a difference. We find the same pattern when we ask students to predict what grade they're going to get in mathematics, in calculus. You can think of this as a measure of confidence. And again here we see that women expect to do better in the course when their professor is female rather than male. Male students expect to do the same regardless of the gender of the professor. I should say that these students know that the grading is done blind, and the grading is actually shared by all professors across all sections. So it's not as if these women are expecting their female professors to be more lenient. They can't because they don't know who the student is and whose exam they're grading. So this is not a leniency effect, it's just that these women feel more confident when the professor is female rather than male in their own calculus ability. So compare this graph with how they actually do. If you look at their actual grades, you see that women outperform their male peers across each and every section where we collected data. So women are actually doing better in calculus than their male peers across all 15 sections of the study. So clearly these students have the ability in calculus. That's not the problem. The problem is that their confidence is far more fragile. Their confidence jumps up when the professor is female relative to when he is male, but their actual performance holds steady. So the takeaway from the study is that the gender of the professor, which students, by the way, during debriefing think makes no difference to their performance, actually makes a huge difference. And that difference is apparent in their implicit attitudes, identification, and their confidence. It's not apparent in their explicit self-reports. So we then wondered what would happen if given that there is a scarcity of women in STEM fields, what would happen if students don't have access to professors of the same sex? Would the same sort of social vaccine effect happen if students get exposed to women who are professionals in any kind of STEM field? So we wanted to see whether exposure to female scientists and engineers who, through a media manipulation, would have the same effect as exposure to a professor. So what we did is this time we went to engineering, our College of Engineering, and we recruited students who are who are interested in majoring in engineering. And this is a simple lab experiment. We randomly assigned them to one of three conditions. We either showed them pictures and biographies of female engineers, so people who are in industry, who are in academia, who are in government, who are electrical engineers, civil engineers, mechanical engineers, different types of engineering. Or we randomly assigned them to see male engineers, or we randomly assigned them to a condition where they read about engineering innovations, but we made no mention of the engineer. We made no mention of the gender of the engineer. And then we measured, again, their implicit attitudes, their confidence, their career aspirations. What we found is that the women, these are all women, by the way, the participants here are all women. The women who were randomly assigned to read about female engineers showed significantly more positive attitudes towards engineering. This is an IAT measuring attitudes towards engineering. Whereas those who read about male engineers or in the control condition actually showed negative implicit attitudes towards engineering. We then looked at this group and we asked, does identification with those engineers affect students' own career aspirations? And we found that those who had been assigned to read about female engineers, the more they identified with her, the more confident they felt about their own engineering ability, which in turn predicted their intentions to pursue an engineering career. And this pattern of data didn't happen for students who read about male engineers. So the takeaway from this is that even reading media stories and narratives about successful women in a STEM field like engineering has the same effect on these women's attitudes towards the field, on their confidence in their own ability, and their aspirations to pursue that field in the future. So, so far, our sort of initial work was looking at the impact of experts. Right? So experts who are professors, experts who are in industry, experts who are out there in the media. But what about peers? Do peers have an impact on these students in a way that has the same sort of social vaccine effect? So that's the question we turn to next. And my students and I predicted early on that peers will have a particularly strong benefit when students are at transition points in their life. By that I mean when students are transitioning from high school to college, college to graduate school, or college to their career, it is in those transition points that they're most likely to feel self-doubt, worry if they fit in, worry if they're good enough, worry if they have enough skills. And it is in those points of vulnerability where a same-sex peer might have the biggest impact. So we wanted to test this idea. So again, we went back to the College of Engineering and we conducted a study on peer mentoring. This has been a monster of a study where we've been conducting this for the past 4 years, since 2011 actually, where we recruited students who were coming in as first-year students in their first week or their first month of college, who were interested in engineering, potentially majoring in engineering. And we randomly assigned them into one of 3 conditions. We either gave them a female peer mentor, here it is, a female peer mentor who was a senior in the same major, or we gave them a male peer mentor who was also a senior in the same major, or in the control condition, they had no mentor. The mentors are people we had recruited, and we had trained them before the academic year started to provide academic support, social support, all kinds of stuff. And the mentor-mentees met once a month, and the mentors provided whatever support their mentee wanted. Their mentee was always a female pre-engineering student, and the mentor was the senior student in the major. So the mentor-mentees met once a month and for 1 year, and at the end of that year, the mentors graduated from college, right? They were done, they graduated, the mentoring relationship ended. And we kept track of how the mentees did. So we had multiple time points where we measured the mentees' outcomes on a whole host of measures across the 4 years, including their retention in engineering. I'm going to show you data from the first 2 years of the study. So one of the things we measured is students' sense of belonging in engineering. How much did they feel that they fit in to engineering or not? And we found that having a female mentor had a huge effect in a way that looked very different from the other 2 conditions. So here's what the graph looks like. On the x-axis, on the horizontal axis is time, from the beginning of the academic year, their first year, to the end of the first year. On the vertical y-axis is change in belonging. So positive numbers means that their sense of belonging in engineering is increasing across the academic year. Negative numbers means that their sense of belonging in engineering is decreasing across the academic year. Yes?
Was the belonging measured implicitly or explicitly?
Good question. So the question is belonging measured implicitly or explicitly? In this case, explicitly. We asked them questions like, how much do you think you fit in to engineering? Do you think you feel left out? Do you feel that you're similar to other people in the major? So there's a whole scale on sense of belonging, and we took part of that scale, and so these are all explicit measures. But we didn't ask them anything about their mentor, we just asked them about the major.
Was there a reason that you didn't include implicit feelings in this study compared to the other one?
Yeah, so we did include implicit measures in this study. It wasn't easy to measure belonging using an IAT, because an IAT is sort of a very simple idea of measuring associations, right? So asking people to associate me with belong would not get at belonging. So it's a much more complicated concept that isn't easily measured using IATs. We did measure IATs to measure implicit attitudes, identification, and stereotypes, and about engineering. And what's interesting is that in the first year, having a peer mentor had no effect on those IATs, but it had a huge effect on these things that I'm going to show you now. And we don't as yet fully understand why that is. But so far it seems like seeing successful experts has a big effect on implicit attitudes and identification. But seeing peers has a big effect on belonging, threat, challenge. And those are always measured explicitly. And I don't yet fully have a grasp on theoretically why that is. But if you have thoughts, I'd love to hear it. Okay, so what you can see here is that the students who had been randomly assigned to a female mentor, their feelings of belonging in engineering stayed stable across the year. Sloped up a little bit, but non-significantly. But basically, what their feeling of belonging in engineering at the beginning of the year stuck around at the end of the year. Those students who had a male mentor or who had no mentor, their feelings of belonging plummeted by the middle of the year and kept dropping by the end of that first year. We found the same pattern of data when we looked at students' confidence or self-efficacy. Again, the students who had female mentors, their self-efficacy stayed stable. Whatever it was when they came in stayed stable, and that's why it's at the 0 line. But those who had male mentors or no mentors, their confidence in their own ability dropped significantly across the year. So these data are all analyzed using HLM, even though the graph looks like it's regression, but this is all HLM. When we looked at retention at the end of the first year, big significant difference. The women who had female mentors were 98% of them who were still in the major. Those numbers dropped significantly in the other two conditions. We then followed up these women 1 year later. So now it's 2 years after 1 year after the intervention. By the end of their second year, we asked them about their career aspirations. Are they interested in majoring or in pursuing advanced degrees in engineering? And again, we found, first of all, notice that the line goes down. So everybody's interest in engineering, graduate school and advanced degrees, as the material becomes more difficult, begins to slope downwards or drop. But that drop is not significant for the students with female mentors, but that drop is very steep for the students with no mentors and somewhat steep for the students with male mentors. In other words, even when that mentoring intervention is done, the social vaccine effect is still persisting in year 2 and the sophomore year of college. And so we are following these students into their senior year, and we're going to see what happens to them at graduation. What percentage of them are still in the major. So the takeaway from this study is that just as having a same-sex expert acts as a social vaccine for women in STEM fields, so too having peer mentors who are only a couple of years more senior to the student has the same sort of effect. Okay, so I want to give you one more example. We know that in science and technology and engineering especially, teamwork is critical. Students often learn in teams, classes often function in teams, and technical innovation often happens in teams. Well, it turns out that the gender composition of the team has a huge effect on women in those technical fields, especially in fields like engineering. So we wanted to test whether the critical mass of women in engineering would have a social vaccine effect on female students. So again, we conducted a study where we wanted to see whether the gender composition of engineering teams would have an effect, would have an impact on female students. So we went to the College of Engineering and we recruited female students for a study on teamwork. So they came into the lab and we randomly assigned them to one of 3 teams. Teams where women were in the majority, so 3 women with 1 man. Teams with gender parity, 2 women, 2 men. Teams with female minority, 1 woman with 3 other guys. What the students didn't know, but what you should know, is that in every team there was 1 real participant. The 3 other students in the team were our research assistants who were engineering majors, but who were trained to behave in exactly the same way across every session. We were only interested in the real naive participants' experiences and behavior in those teams. So we randomly assigned them to the team. We gave them a team task, 2 engineering problems to solve as a team. And we were interested in the women's experiences on the team. So we measured how worried and anxious they felt about the team task, how eager and motivated did they feel about the team task. We measured how much they actually participated. Were they quiet or were they active? How engaged were they? Did they help solve the problems and so on? We measured their confidence or self-efficacy in engineering. We asked them about their career aspirations after the team task. And we measured their implicit stereotypes about engineering. How quickly did they associate engineering with males versus females? Yes?
Why didn't you have a group
All
with
female?
women only?
We wanted to. The reason we didn't is entirely pragmatic. Women are 20% of the majors in engineering. So in order to have an all-female group, we would have had to, this study took 5 semesters just to get those, 120 women. So it was just not worth it to have an all-female group. Also because, it wasn't worth it, also because there are existing studies that are published that compare teams with all women with teams with only one woman. And so we thought what was really unexplored was what happens when you grade the percentage of women in between, being a solo versus all women. So one was a pragmatic reason, and the other one was that we felt that the answer to the 100% female group was already known. All right, so when we looked at how threatened or challenged these students felt in the teams, this is what we found. So here, the y-axis is how much threat students felt relative to challenge. So it's a ratio. So higher numbers basically mean more bad stuff. Higher numbers means that they're feeling more worried and anxious and less eager and motivated. What you can see is that the women who were the only woman on the team were most worried and anxious about working in the team, whereas those in the gender parity team and in the female majority team were significantly less worried and anxious. When we looked at how much they spoke up, we found similar patterns of data such that women in the teams where 75% were women, a critical mass of women, spoke up the most. They were the most engaged, they were most likely to help solve the problems, but the other students who had been randomly assigned to teams with fewer women were much more likely to be silent in the team. And by the way, because we know our research assistants were trained to behave exactly the same way, we know that these women are not more quiet because they were dominated by the men on the team. They were quiet because they just, and this is part of the stereotype threat effect. We then looked at women's confidence. And what we found is that the students' confidence suffered if they were in female minority teams, especially if they implicitly had internalized the gender stereotype about engineering being a masculine domain. So here is what the graph looks like. On the x-axis, you have how strongly these students showed implicit stereotypes about engineering. So these are women who had strong implicit stereotypes about engineering, and these are women who had weaker stereotypes about engineering. And on the y-axis, you see how confident they felt about their engineering ability. So what you can see is that the women who were assigned to be the only woman on the team, the more stereotypes they had in their mind, the less confident they were about their ability after working in the team where they were the solo. But women in teams with a critical mass of same-sex students, even if they had stereotypes about engineering, they were essentially inoculated. They were able to resist those stereotypes and maintain their confidence. Same pattern of data when we looked at career aspirations. The students who had stronger implicit stereotypes about engineering, if they happened to be assigned to the female minority teams, the more their implicit stereotypes about engineering, the less they were interested in pursuing engineering careers after having worked in those teams. But the students who were in teams with a critical mass of women, their interest in engineering careers held steady, and they were able to deflect or resist the stereotypes, right? So the takeaway is that even if somebody has learned the stereotypes, whether or not those stereotypes will affect someone's own confidence and their own career aspirations really depends on their social context. If they are in a social context where they see other people like them, they are able to be resilient against the stereotypes. If they are in a context where there are very few people like them, then they are not able to resist it. And then slowly their confidence drops, and with it their aspirations to pursue STEM careers, which you essentially saw in the mentoring study. All right, so I've thrown a lot of data at you. So what I want to do in the last few minutes is to take everything and boil it down to 5 takeaway points. So essentially 5 solutions that I think are effective if we want to turn the tide and increase not just recruitment, but retention of women in STEM fields. And I think the solutions I'm going to mention are relevant both at the university level, but I think they're also relevant in middle and high school. So first, our data suggests that one important solution is to increase girls and women's contact with female teachers and professors in STEM fields. Because when students see experts who are from their own group, that has a huge effect in allowing them to envision similar success in their future. Second, our data suggests that we need to encourage mentoring relationships between beginning students who are in sort of exploring the possibility of majoring in STEM fields with advanced peers of the same sex. Third, even when the numbers of women who are professors and experts in technical fields is small, we could and we should showcase the success of technical women in other ways, through media stories, through guest speakers, through internships, through visitors, and so on. Four, when designing team projects, pay attention to the gender composition of those teams. Avoid teams with only one solo woman. And finally, timing matters. Some sorts of interventions, a lot of our research shows, and I've only shown you a smattering of it, some sorts of interventions are particularly effective in those transition points when people are most vulnerable to self-doubt. And once they feel that they fit in and they belong, then they sort of rise and shine. But in those moments of transition, that's when you need the intervention most. So let me end by saying that even though I'm the one who's presenting this, in science, it is not I, it is we. None of the work I do would be possible without my team, my grad students and my postdocs, colleagues in mathematics and engineering who opened the door and allowed me to come to their college or their department and collect data. Funding from the National Science Foundation, without which there is no way I could have done this labor-intensive work, and a big army of undergraduate research assistants who do the actual data collection. So, thank you very much. Let me, all my published work can be downloaded from my website. That's the URL. And it's all password protected for copyright reasons, and the password is published. So if you're interested in reading any of the full text of the published work, except for the mentoring study, everything else is published. You can download the papers. Yes?
I had a question because I was wondering why the positive optics is better when there is mentoring on your own sex rather than I am concerned when there is mentoring from the opposite sex. If you go back to the results on that,
Yeah.
That's the most worrisome part. The effect is not staying; it's negative actually. So one of a larger question that I had was, to what extent do you think that it's an interaction issue, that it's actually males are suppressing interaction? But one specific question that I had is that the attitudinal effects that you show tend to indicate that the control is the worst, but the empirical, like the actual retention, the control is better than the male condition. So how do you explain that inconsistency?
Right. So let me take the first thing first. So am I heard at the back? Yeah? Okay. Maybe I'll just use the is that okay if I use, did you take that mic? Okay.
Or maybe this one? ¿Funciona mejor? ¿Funciona bien? Okay, we can use
Oh,
this.
wait, maybe we can just stop. Is this clear? No. Okay. So say it again. Our hypothesis originally was twofold. So we thought that having a female mentor would have a big benefit, but having a mentor would also, regardless of gender, would have a benefit. We found support for the first hypothesis, but not the second. So it is a bit of a surprise for my student collaborator and I that having a male mentor has no effect and sometimes looks like it has a worse effect. But actually it doesn't have a worse effect because it's never different from the control condition. The difference is always between the female condition and the male condition. So that's one answer. We look to see what the mentor and mentees talk about. So what I didn't say is that the mentors keep an online diary, what they did together, what they talked about, how long they met, and we've analyzed all of those data. And interestingly, there are no mentor differences in what kind of mentoring they do, the content of the mentoring, the frequency of the mentoring. So there's no quality difference, there's no quantity difference. So I think the effect is an effect of identification.
The women are more likely to identify with the same-sex mentor than the different-sex mentor, even though the quality of mentoring they're getting is equal. So it's likely that they feel that with the male mentor, they're less, even though they admire him, they're less likely to achieve that. But if you just simply change the gender of the person, now they feel that they're able to achieve her success more. In terms of the retention numbers, the retention difference is actually significant, again, between the female condition and the male condition. The difference between women, the retention, 98% retention for female mentors is significantly different from the male mentors, and the control condition, again, lies in between. So it's never the case that the male mentors are worse than control. It's just that they're worse than the female mentors.
Vamos a
First of all, I would like to thank you, Guji, because it's such an inspiring opportunity for me to listen to you and clarifying a lot of doubts, and also comparing what you've been doing with some research that's been happening in Chile also, about comparing the effect of the gender of teachers for secondary students. In one study I found. In the Universidad de Diego Portales, they did something similar in 2009. But my question is about actually if you think it's in any way the difference in the effect of this vaccine, positive vaccine effect that the female teachers have on female students can be explained by different in the teaching practices in comparison with us, because you said when you presented the results of the first study that basically the changes in the attitudes were almost immediate. But there's some theories that we can think that there are differences in the way female teachers relate with students or the styles of teaching and so on. So I'd like to know your opinion.
That's a really good question. I think there are. I don't know if there were in the calculus study I talked about, but we're doing this project now that I was telling the team I was talking to earlier today, looking at middle school. And there we have observers in the classroom who are measuring classroom teaching and learning styles when the teacher is female versus male in math classes and in science classes. So our hypothesis is that it's not necessarily the gender of the teacher, but I think it is the teaching style. So the working hypothesis, we don't have the data yet, is that teachers who use more applied ways of teaching, especially mathematics, where the teaching is much more tied to real-world concepts, where there's some data, there's some research by other people showing that girls and women are much more interested in pursuing fields that are much more applied. Applied meaning that they're more tied to real-world problems. And if they understand the link between the technical work and the real-world problem, those are the fields they're interested in. And when the teaching style is much more abstract, then their interest, even if they're good at it, they're less interested in pursuing it in the long run. So that's one hypothesis, applied versus abstract teaching. The second hypothesis is that teaching styles that are much more collaborative classroom practices rather than competitive, where you pit one student against another, where students compete for the teacher's attention, is likely to be a turnoff for girls and women. And teaching styles that are much more collaborative are more likely to attract more girls and women. So we have a bunch of hypotheses that really focus on classroom styles, and we think sometimes the gender of the teacher or professor might determine the way they run the class, which in turn might affect student outcomes. So that's one pathway. But I do think that in some cases, especially in fields where there are very few women, like mathematics and engineering, especially at the university level, having a professor being female does have an additive effect. It would be my sort of hypothesis now.
Thank you very much indeed for your study and to show us different reality. But got to know curiosity. All these female students are the first generation American or immigrants?
That's a very good question. They are the undergraduate students that I have in the study are less likely to be first generation. But in the engineering and the mentoring study that I was showing you before, we do ask questions about various things: immigration status, social class, and what their parents do. Even if they have a college degree, are they in a technical field or are they not? We don't have enough immigrants in our sample to look at the effects of mentoring for students who are immigrants versus not. But we do have enough data to look at the effects of mentoring on first-generation students versus students whose parents went to college. And there we see that when it comes to student grades, having a female mentor matters particularly for first-generation college students. For them, their grades go up when they have a female mentor relative to male mentor or no mentor. For students whose parents went to college, who have a college degree, their grades are not affected by the gender of the mentor. So I think for students who are particularly vulnerable, like first-generation college students, that's where the social vaccine is needed more. I can't answer the question about immigration status, but if I had to guess, I would say that there's sort of two possibilities. One possibility is that they would look very much like the first-generation students. Another possibility is in the US, and I'm curious to see whether it's similar here. One pathway to, I was talking about this in the morning as well, one pathway to social mobility for immigrants is to go into technical fields, because you know you can get a degree and you know you can get a job. And your primary responsibility or goal is to get a job. So it's more likely, I think, for immigrants to want to major in STEM fields, because the likelihood of jobs post-college is much higher. So it might be that immigrants have some other motivation to persist despite obstacles in a way that US-born students will or may not. So that's an open question.
My question goes in a very similar way, but do you measure race or socioeconomics in the sense to be an interaction? Because I'm thinking that maybe the vaccine
Yeah.
won't work the same way in some groups than another. I'm thinking, because I work in a context in the south that is Mapuche,
Yeah.
and I don't think that for the girls meeting me, it's doing so much different as is doing that I work, my co-worker is Mapuche, and she does different, she connects with them. So do you think that for those things will be an interaction or another pathway?
So you're actually asking a really important question, which in the US literature is often called intersectionality. What is the intersection between two social identities? And it's particularly important because there are some people who study race, there are some people who study gender, there are some people who study social class. Very few people study the intersection of these identities. And partly it's to, and I am guilty of the same thing, it's partly because of where your sample comes from. So in this study, I can't tell whether race will interact with gender, because my students of color in this population, if I combine Black, Latino, and Asian American and Arab students, if I combine all of them, are no more than about 20% of the sample. But in a recent study I was talking about a little while ago that's being done in middle school, I'm particularly interested in whether students who face both gender stereotypes and racial stereotypes, just like your Mapuche students, would be particularly vulnerable to stereotype threat, and if having same-sex peers in the classroom would be protective for all girls or only white girls. And so I don't have the data yet, but I'm doing that study comparing girls in math and science classes in single-sex classes versus co-ed classes. And in each class, there are enough girls who are minority girls and white girls, minority girls and white. So I can do the comparison to see is our same-sex peers protective, have a social vaccine effect for all girls, or just girls who are white, because that's the assumption that if that you're white, but that for girls who are a racial minority in a single-sex class, they might still feel pretty stigmatized because they are a racial minority, even though they're not a gender minority. So I don't know yet. I don't know whether for your Mapuche girls, whether a better social vaccine would be a same race person or a same gender person or somebody who matches on both dimensions. That's actually it might be good to, in your case, to ask your students questions just to get some initial preliminary data to see who do they connect with more, who do they identify with more.
Thank you for the great talk. I'll try to keep my questions short. 2 questions, in fact. My first question is, well, let's start with my reflection. So it's great that there are interventions that make females to take on STEM professions, but what about males?
Mm-hmm.
We need males to take on some professions like nursing or psychology. Is there any data, or do you have any data on such interventions with males, for instance, like mentoring for males, or right, because there may be males who feel pressured to take on those scientific professions that are better paid, etc. And my next question is related to the first one, because actually both of us, we are participating in an intervention, mentoring intervention for immigrant children in Spain.
Okay.
And the mentors are psychology students mostly. So what are we doing to those young girls? Maybe it's detrimental for them then to be mentored by psychology students, female students. Do I explain myself? And what happens to boys, for example, when they are mentored by, for example, male psychologists? So what do you think happens there? Because now I'm kind of scared.
So let me make sure I understand this right. Are you mentoring them in general? Are you mentoring them in a particular discipline?
No, generally, just intervention that favors social integration.
Okay. So I think so. I'll take your second question first and then go to the first one. I think that if the intervention if the goal of the intervention is about social integration, then the expertise of the mentor, being a psychologist or a scientist or a physical scientist or an engineer, doesn't matter. It's not relevant. The expertise of the mentor matters when we're trying to mentor students who into a field where they are a minority, right? So that's where I think the subject matter of the mentor matters more. So I think having both of you as mentors of immigrant children into Spain will work just as well. What I would actually be curious about is what would happen with the 2 of you as mentors versus other immigrants of second generation naturalized Spanish citizens as immigrants, as mentors. That would be the interesting comparison. So do students acculturate more if they have a mentor who is born in Spain?
That's a great idea.
Yeah, versus. So I think that's so. In your case, the mentor's field doesn't matter. It's the mentor's citizenship that matters more, because your outcome variable is social integration. Your outcome variable is not pursuit of a particular field. Okay, so now to your first question. I think so. There's a lot of research showing that at least in U.S. samples, men who are in a numeric minority in fields like social work and nursing, even though they're in a numeric minority, they're not stigmatized, which is to say that their leadership their trajectory for promotion is actually steeper than for females in the same profession. So numeric minority status is not the only variable. It's a negative stereotype attached to your group's ability. Is there a doubt in the culture that people like you will succeed or not in that field? I think that matters more than the number of people in the field. So those data show, looking at men in nursing, there's some sociological studies of men in nursing, comparing that to women in business. And they show that the negative effects are much more for women in business than men in nursing in terms of promotion. So I don't think that in this case men will need the interventions, but I do think that there is a pressure, more of a pressure for men, and in the US for Asian American men, to major in fields that are technical. And that's partly because their parents, going back to the immigration question, their parents are immigrants, and their parents sort of push them to go into fields that are more lucrative, that are more stable, not to be artists, but to be scientists, not to be poets, but to be engineers. And so I think that's actually a sort of a leftover of immigration status that faces men especially. But I don't think numeric minority status hurts men in professional life in STEM as much as it hurts women.
Yeah, I offer myself to have a question, and there is one in the back. So I will ask the question, and then David, you have a question at the end? No? Well, okay, start with mine. Going to the vaccine idea, I was kind of puzzled with the idea that implicit attitudes were changed so rapidly in the context of the expo when students had the teacher. And I'm wondering, because I mean, for one thing, I didn't expect them to shift so quickly, but what happens when those students go back to the normal context in which males are the teachers? So does that mean that they will lose whatever? I mean, because the vaccine to some extent is a protection for future diseases. So this is a question I have for maybe for future studies because there is some indication, I guess, in the mentoring study that this going down effect, which is probably a mixture of the different kinds of context they have later in the context, but they went down in a way less. Yeah. Okay. So that's one question I have. Second question is something relevant to our context. Here there is a big interest in expanding social diversity in university. So we are pushing for measures to ensure that we have more students coming from lower socioeconomic backgrounds, and in many cases they come in very small numbers to schools. And I think there is a lot to learn from these kind of studies in the design of those situations, because if you bring in just one or two in a context where they have, like in this university, 90% of students coming from very wealthy environments, some schools, it will be something that could be even detrimental in the long term. My third point, or concern, is you touched the point of this is something that is in our school context. We have many schools that are same-sex. And some people say that it's good for women to have same-sex schools, especially in fields like math and science. Whereas there is another concern about this, say, normal development, which involves the interaction with people from males. So what's your point about your take about that particular aspect?
Okay.
So that's for the last slide. Okay.
All right. So let's see.
First
I'll go with the recency effect. I think to the third question. I think the takeaway from my study is not necessarily single-sex education. It's more about paying attention to having a critical mass of girls and women in the learning environment. So to try, to say it differently, avoiding situations where a very small minority of students are girls or women in those classes. So in our engineering studies, for example, women in our engineering studies are usually, as I said, 20% of the major. But if they are learning in teams where at least 50% of the students are women, I think that provides a social vaccine, even though they are in very small numbers in the class. So For example, we have a study going on that follows from the PNAS paper about teamwork in engineering, where a colleague of mine who was the past provost of UMass wrote to me and said, I saw your paper in the National Academy of Sciences. I teach a biochemistry class which involves team-based learning, where students are assigned to 3-person teams and they stay in those teams across the semester. I always thought it would be better to have women spread out across all these teams. Your study seems to suggest that we need to cluster them in some teams. This seems like an ideal collaboration. Do you want to come to my class and do a study? So my postdocs and I are doing a study in his class where we randomly assign those students, male and female, into all female groups, all male groups, 2 female, 1 male, 2 male, 1 female. Right? And our goal is to see, we measure their performance, their individual performance, team performance, grades, career aspirations, to see whether the team composition, the microenvironment, acts as a protective, even though the macro environment may be more skewed in terms of gender. Which then leads to the second question you asked about social class. I do think that, sort of where you're going is that this critical mass idea suggests that students are much more likely to succeed if they come into a wealthy college environment and they are one of very few people whose parents didn't go to college, if they have other people like them that they can connect with. So in the US, there are all of these orientation programs for first-year students coming into college, where there are special programs for first-generation college students, where they have a pre-orientation where they meet other students like them, whether they meet mentors who are also like them, who are advanced students who are first-generation college students. And the goal is to create a social support network before the rest of the students arrive, so that they already have a place where they belong. And I think that the survival rate of those students through college, through degree, is likely to be higher than students who get a general orientation, but the other students are not like them. And then to the first question, I think some of my earliest work, starting in my years as a postdoc with Tony Greenwald, we found that implicit attitudes are very malleable, that you can put people in an experimental situation. In our early research, we found you put people in a situation where we showed them little media stories about admired African Americans and white serial killers, and we then measured their implicit racial attitudes. And we found that the typical big implicit preference for whites over blacks completely decreases when they see those images. But I think if they were left to their own devices, in a regular society where media images of criminals who are disproportionately represented as black, I think that bias would come back. So to apply to this study, I think that in those students in that first calculus study who showed increased positive attitudes towards calculus after having a female professor, if the 10 other professors after that are male, I think again their attitudes will drop over time. So that's one sort of answer. But I also think that there is that critical window when that positivity or negativity of the attitude matters more. So a student who makes it through their sophomore year, makes it through the first 2 years of college, are much more likely to keep in the same major. So I think that the risk of dropping out of the major is most likely in the first 2 years, in the beginning. Yeah.
Okay, the last question, David.
Just a follow-up on the...
Yes.
I'm interested in why you say that the implicit attitudes are malleable and not simply that the results of the IAT are malleable because of a priming issue. I'm wondering to what extent do you think that it's just not an artifact of the instrument that you use to measure implicit association as being a function of priming a topic?
Yeah, that's a great question. So we know that because we've used different measures. We've used evaluative priming measures, we've used lexical decision tasks, we've used IATs, and across some of these these measures are measures I've used, some of them have been publications from others, and there's now actually a big literature showing that implicit attitudes measured using a variety of reaction time tasks show responsiveness to context effects. That if you change the context, you change the implicit attitudes. And most of this research has used IETs, evaluative priming, lexical decision, semantic priming tasks, and AMP, Keith Payne's affective misattribution test. So in all of these, you see the same effects.
Thank you.
Okay.
So thank you very much. This was great. I'll be here. If you have any more questions, feel free to come up.
Bien, bueno, ha sido una estupenda sesión. Quiero agradecer muy justamente a Jaime. Creo que todos quedamos con buenas ideas para seguir adelante después de esta sesión. Así que le agradezco a todos su presencia, su interés. Agradezco, por cierto, a Jaime Abuyu. Y como les decía al comienzo de esta sesión, pronto a través de nuestro sitio web seguramente vamos a anunciar cómo vamos a seguir el próximo año con esta idea de activar la psicología política en nuestro medio. Seguramente el próximo año trataremos de realizar un seminario y algunas otras actividades. Les mantendremos al tanto. Muchísimas gracias.